Hello everyone. After understanding the simulation of basic gates using pspice, let us explore how to simulate a fundamental digital circuit which is known as half adder using pspice. As you can see over here, half adder is a combinational circuit which takes two inputs A and B and gives two outputs sum and carry. Basically, what does this circuit will do is it gives the Boolean sum of A and B. What do you understand by Boolean sum means? If 0 0 appears as an input, then both sum and carry will be 0. If any one of these two inputs is 1 and the other input is 0, then sum will be 1 and carry will be 0. If both the inputs are 1, then sum is 0 and carry is 1. This is what the circuit half adder functionality. Now let's try to design this circuit and simulate using pspice software. Basically, the half adder circuit involves two fundamental gates which are known as XOR gate and AND gate. In order to find these two gates, we have to go to this get new part. Under get new part, I am going to find XOR gate. The IC number for XOR gate is 7486. Under 7486, you can see in the description says to input XOR gate. I'll pick one XOR gate, place it, and I need one more AND gate. As we all know, 7408 is an AND gate IC. I'll take one AND gate and place it. In order to do circuit connection, we require digital stimulus. For that, I'll pick digital stim. We'll be requiring two digital stimulus, one for each input. So I'm taking two digital stimulus. In order to measure the outputs, if we are going to take if out, I'll take two if out, one for sum and the other one for carry. These are the things we require in order to design a simple half adder circuit using fundamental gates or basic gates. Now I'll rename them. I'll rename them as A and B, and I'll give the name for the output as sum and carry. Then I'll make the circuit connection. Input A is connected to one of the input, one of the input of the XOR gate, and input B is connected to another input of the XOR gate. Similarly, the same connection will be done with the AND gate. Then the output of XOR gate is connected to sum and the output of AND gate is connected to carry. Now this is a simple circuit which will perform Boolean half adder functionality. As I told, if 0 appears on any one of these inputs and 1 appears on the other input, then sum will be 1, carry will be 0. If both the input has 0, then sum and carry will be 0. If both the inputs are at 1, then sum will be 0 and carry will be 1. Let's see if this circuit will give the proper result or not. In order to do this, I need to give the input. In order to provide the input, I just need to double click on it. As we have taken in the previous case, I am going to consider period and on time. I have given the period of the digital input A as 4 milliseconds and on time as 2 milliseconds. I'll keep it as it is. And if I check the period and on time of digital input P, the period is 2 milliseconds and the on time is 1 millisecond. I'll keep it as it is. After this, I just need to do one setup for this simulation. I'll go to this setup analysis. Under setup analysis, I'll go for transient. Under transient, I'll give the final time and the step size. Let me take the final time as 10 milliseconds and the step size as 1 milliseconds. With this, we are ready to simulate this simple half adder circuit. We have taken XOR gate from the IC 7486 and AND gate from 7408, two digital stimulus and two outputs. I'll take the voltage level indicator and keep it on some carry and the two inputs. After this, let me simulate. If I press this icon, the circuit gets simulated. As you can observe, we have two inputs and two outputs. If I have a look at this, these are the inputs and outputs, and in this section you can see both the inputs are 0 0, so both sum and carry are 0, and in this section A is 0 whereas B is 1, so we will be getting sum as 1, carry as 0. And in the next section I have A as 1 whereas B is 0, hence the sum will be 1, gain carry will remain as 0. Whereas in the final section both A and B are 1, hence sum is 0 and carry is 1. The same thing continues for the next cycle. Since we have taken 10 milliseconds as the final time or the run time of the circuit, you can see this is what the 10 millisecond, and one time period for A is 4 milliseconds. From 0 to 4 I have one cycle, and for B I have 2 milliseconds time period. 0 to 2 I have one time period, one full cycle. Okay, with this we have seen the simulation of half adder circuit using pspice software. Fundamentally, we require these two gates. Half adder is a functionality which can be achieved by using two logic gates. One is XOR gate and the other one is AND gate. In the next video, we'll be understanding and designing full adder using logic gates. Why we need to go to full adder? Let us understand that this is a simple circuit which adds only two inputs. I cannot have one more input, and I cannot add 3 bits at a time to get sum and carry. This is what the drawback of half adder circuit. In order to overcome this drawback, we will be implementing full adder circuit. What does this full adder circuit will do? Along with adding two inputs, it will take one more input and add 3 bits at a time. That circuit we call it as full adder. In the next video, we'll be looking at the simulation of full adder circuit using pspice software. Thank you.